So in this video, we're going through the problems on page 5 in your literal equations packet. And there are a few problems that I have starred here first, and they are problems where you're going to need to factor, which is the new skill that I recently taught you guys. And the problems that have a heart next to them are the problems where you're going to need to use the heart method. So again, the stars are for the factoring problems, and the hearts are for the heart method. So we're going to start up here for number 15. And we're trying to solve this equation for A. So the first thing we're going to do is to get rid of the constant. So we're going to subtract the b on both sides, and over here the best we can say is that it'd be z minus b. Now this cancels out over here, and we're left with m over a. Now since a is in the denominator, I'm going to multiply it on both sides, so it cancels out over here, and that has solved the equation now for m. Now a is on this side, and it's a times this thing right here. And so since this is a multiplication thing with a, I've just moved my work up here. We're now going to divide both sides by the z minus b, and it'll cancel out. So now a is all by itself, and we have m over z minus b for this final answer. All right, now we're moving over here to number 16. So for number 16, we're trying to solve for x, which is here, it's just a constant with two other constants. So since we have a positive c, or a negative c, I should say, we're going to add c on both sides, and that cancels it out over here. So we have g plus c, and then we still have a positive y, so we're going to subtract y on both sides, and so it's g plus c minus y. And you might have thought over here to subtract the y first on both sides and then add the c. So if that's the order you would have gone in, then you'd see g minus y plus c. And notice that we still have a positive c and a negative y, so those are the same answer. Those are both equally acceptable. For number 17, solving this for a. So first we got to get rid of this constant. Since it's a positive b, we're subtracting b on both sides, so it cancels out, and we have g minus b over here. Then on this side we're left with a negative c, a. So now we're going to divide both sides by this negative c, so that a is all by itself, and we have g minus b over negative c. For number 18, solving for a. So there's a negative b right here as a constant, so we're going to add b on both sides, so g plus b. And then simply to get rid of the coefficient, we divide both sides by c, so it's g plus b over c. Now number 19 is a problem where you're going to need to factor. And so for number 19, the reason I know we need to factor is because as it starts out, I've got an x on both sides. So the first thing that I'm going to do is I'm going to leave the 4 alone, and I'm just going to subtract the 2x from both sides. So that essentially means I'm moving the 2x over to this side. So the 2x over here would cancel out, and now I've got this xg minus the 2x. So now I have an x in both of these terms, which means I can factor out the x. So if you distribute, x times g would be the xg, and x times negative 2 would be the negative 2x. So right here we factored out the x. So now we've got x times g minus 2. So now I can just divide both sides by the g minus 2, and now x is all by itself. So x here equals 4 over g minus 2. For number 20, we're going to use the heart method because we have a binomial in the numerator, and then we have it being divided by one term. So I've got the 1 over a. When I divide 1 by a, I get 1 over a. And over here, 2a over a, if you have a 2a, 2 times something, and then divide it back by a, it's going to be right back to 2. So pretend this was a 4, for example. 2 times 4 is 8, and if you divided that by 4, you'd be right back to 2. So that's why the a's cancel out, and you see that I've got just a 2 right here. So I still got g over here, and it equals the 1 over the a plus 2. So now I just have a constant that I'm going to subtract on both sides. So on this side, I'm left with 1 over a, and the 2 cancels out. And over here, I've got g minus 2. Now, since a is in the denominator, I'm going to multiply a on both sides. So over here, I've got a times g minus 2. So since it's a times g minus 2, and we want to solve it for a, now we're going to divide both sides by this term, and a is 1 over g minus 2. For 21, once again, because we have a binomial and in the numerator and just one term in the denominator, we can start with the heart method here. So we've got x over x, and that's a 1. Anything divided by itself is 1. And then we're going to subtract here c over x. That leaves me with a constant, so I'm simply going to subtract. So over here I've got the g minus 1, and on this side I'm left with negative c over x. Now, since x is in the denominator, I'm multiplying both sides by x, so that's an x over here. And because we want to solve it for x, now I've got x times g minus 1, divide by that g minus 1, and we still have the negative c in the numerator, and divided now by g over minus 1. Now for this problem right here, I'm actually going to get a new screen, and I'm going to show you guys that if your reaction, when you see the x minus c over x, I'm going to show you that you could start by multiplying both sides by the x. I think for a lot of you that's going to be your instinct, so you might want to cross that out here. Now you've got x minus c in the numerator equals xg. So now what you can do is you can subtract this x from both sides. And so over here you've got xg minus x, and on this side you'd still have your negative c. That means over here now you can factor out the x, and it'd be multiplied. X times g would give you xg, and then x times a negative 1 would give you the negative x right there. So now if you're trying to solve for x, what you can simply do is divide both sides by the g minus 1, and divide here by the g minus 1, and that cancels out, and we still get the same answer, and you've solved it for x, and you still get the negative c over g minus 1. So if your gut reaction when you see the x down here in the denominator is to go ahead and just multiply it on both sides, you can definitely still get the same answer. You'll just factor out your x right here, and you are good to go. Okay? I should have mentioned that probably also back here in number 20. If it's the, let me just double check, was it 1 minus 2a or 1 plus 2a? All right, let me just show that one real quick. Again, I think a lot of people are going to have a gut reaction to multiply both sides here by the a. So we've got the 1 plus 2a in the numerator, and then over a, and that was it g? Yeah. All right, so again, if your gut is to go ahead and multiply both sides by the a here, for it to cancel out, that works. And you're left with the 1 plus 2a for the numerator. And then on this side, it's the a with the g. Now what you can do is subtract 2a from this side, so it cancels out over here, and then subtract 2a from this side over here. And you'd be left with the ag minus 2a equals 1. Now you've got an a over here in both of these terms that you can factor out, and you'd be left with a g minus 2 equals the 1. And now here we are ready to go ahead and divide both sides by the g minus 2. And we get a equals, in fact, I'll just go ahead and write it over here. A equals 1 over g minus 2. So we end up getting the same thing. Okay? All right, now back to this, and we are on number 22. So for number 22 here, we are going to solve it for x. So I've got an x on both sides, so I'm just subtracting x to now have xm minus x. And now because of that x in both terms, I can factor out the x. So x times m would be xm, and x times negative 1 would be the negative 1x right there. And now I'm just dividing both sides by this m minus 1, and x equals the z over m minus 1. So you can see these problems have something very similar going on, where once you factor it out, you're dividing both sides by that term. So by now, you're probably starting to get the hang of that. Here's another one with the factoring. So if we're trying to solve this for a, what I did was I just subtracted ka from both sides, and it canceled out over here. So now u is all by itself, and then I had the ba minus this ka. Now both terms have an a that can factor out. So a is factored out, and then times b minus the k right there. And then I just divide both sides by b minus k, and a is u over b minus k. For number 24, same idea here, solving for x. We can go ahead right here and catch that there's an x in both. So we factor out the x. X times k would be kx, and x times y would be the yx. And now when we divide by the k plus y, x is all by itself, so we get u over k plus y. All right, now we're on number 25 here. So we're trying to solve this for A. So in one step, what I recognized was that I just subtracted the 3b, and I'm going to subtract the 2. So over here, I've got u minus the 3b minus the 2, and that cancels it out over here. And all I'm left with on this side is the negative 2a. Now I can divide both sides by the negative 2, and a is by itself. So we get the u minus 3b minus 2 all over negative 2. And yes, you could take that a step further and go with the Hart method, but because we'd have like a negative 1/2 u, and then a positive 3/2 b, and then a plus 1, there'd be fractions involved, and that just doesn't look good, so we're going to choose not to do that. The algebra teachers next year are definitely going to help you get the hang of when you would want to use the Hart method versus when you wouldn't, and that's why in the video I wanted to go ahead and let you know which ones to expect it on this worksheet. Alright, now we're on number 26. So it's currently solved for z, and we're trying to solve it for a. So it's 9a minus 9 minus 3b. So now what we're going to do is we're going to add the 9 on both sides and add the 3b on both sides for the negative 9 and the negative 3b to cancel out over here. So if I add them to both sides, now they're over here. I've got z plus 9 plus 3b equals the 9a that was over here. Now simply divide both sides by the coefficient for it to cancel out. And a is z plus 9 plus 3b over 9. And just notice for the final answer with the numerator, I chose to put it in, well, I should have put 3b first actually. 3b, and then plus z, and then plus 9. And now it's in alphabetical order, and the constant is last. So the numerator should actually be the 3b plus z plus 9 all over 9. All right, now for number 27. So we've got g equals 4ca minus 3ba, and we're trying to solve it for a. So if both of these terms have the a, go ahead and factor it out. And a times 4c would leave you with 4ca. And if you were to distribute a times a negative 3b, you'd get a times negative 3ba, which is right there. So now you just got to divide both sides by the 4c minus 3b, and a is all alone. So a is g over 4c minus 3b. All right, for number 28, trying to solve it for a. So the a is right here on this side. So I'm going to go ahead and get rid of the constant on this side. And so I've added 3. So now there's just a plus 3 over here. Negative 2n plus 3p plus 3. Now I'm dividing both sides here by the negative 3. And on this side, we get that it'd be in the negative 2n plus 3p plus 3 all over this negative 3. And I just wanted to, again, point out, like right here, if you did the Hart method, you'd get a negative divided by negative, so that's a positive 2/3 n. Here, the 3 and the 3 would cancel out, but it's a negative, so it'd be a negative 1p, which is right there. And then the 3 divided by the negative 3 is a negative 1. So with the Hart method, this would be the final answer. And again, next school year, the algebra teachers are going to be able to talk to you guys about when you want either one of these answers. But for right now, we'd go with this one. All right, we're almost done here with this video. We have 2 more. So we're on number 29. And if we're just trying to solve it for x, we're going to be able to do that quite easily by just dividing both sides by this coefficient. And then over here, actually, I should have Hart method starred this one. I am going to Hart method this one just to show you guys in this final answer that with the negative 4 over 4, that's a negative 1. So there's the negative 1r. And then you have 2 times d over 4. So 2/4 is the 1/2 d. It would be fine if you just left this because right here, the negative 4r plus 2d over 4, because I didn't have a Hart next to this one. But something here, just because this is divisible, and then right here, 2 and 4 reduces easily to 1/2. For this one, I think it's better to go ahead and call this a Hart method problem, and let's go with this as our final answer. And now for number 30, if we're trying to solve it for a. So a is currently in the denominator, and the first thing I did here was multiply on both sides by ka. So multiplying by ka over here would cancel it out. So u times ka is now uka on this side. Now over here I just have the numerator, the negative 2a minus 3, and I'm going to add the 2a on this side. So now I have my 2a plus the uka. The reason I wanted to do that was so that now I could have a binomial, and a is in both of them, and now I can factor out an a. Now on this side, when we added the 2a, all we're left with was the negative 3. All right, so at this point, since I have a times something, I can just divide both sides by that. So that's where you see that I've divided both sides by the 2 plus uk. And that would cancel out over here. So negative 3 over 2 plus uk is our final answer. And I would imagine that because we've talked about this a lot, you probably formatted it with the uk first. And then you have a plus 2 with your constant last, which is awesome if you did that. And then you might have even taken that a step further and switched these around to be in alphabetical order. So you might have had a KU plus 2. And then over with the negative 3 was over all of that. And once again, next school year, I'll let the algebra teachers talk to you more specifically about formatting. But as of right now, I would accept all 3 of these answers. And that concludes the video on page 5. Thank you.